Hello everybody, and welcome back to another video. In this video, I am voicing it over currently, so it might seem off at times. I am covering 2D kinematics. Now the question is, a ball is launched at an angle of 30 degrees at an initial velocity of 20 meters per second. Find the displacement in the x direction when it hits the ground. So we are looking for this distance right here. Now we know that the angle is 30 degrees, the initial velocity is 20 meters per second, and the acceleration due to gravity downwards is negative 9.8 meters per second, and we're defining the up direction as positive and the down direction as negative right now. So as you can see, the y component of this vector and the x component of this vector are just equal to vi times the sine of theta for vy, and vix is equal to vi cosine theta. That's just due to some trig. If you want to look at my vector video, you could check it out. Now, as you can see, the y component at the beginning and at the end are going to be the same, because the net velocity at the beginning of the end are going to be the same. The angle is. That's just something that you need to know for this. You can expand on that further when we get to energy. However, right now, just know that if something hits the ground at the same time, then the final velocity is going to be equal to the negative of the initial velocity. Now, the acceleration is downwards, straight downwards. So the angle made with the velocity is 90 degrees. So the acceleration does not affect the velocity right there. So we know that our x velocity is constant throughout the entire motion, which will help us use another formula later. Our final velocity in the y direction minus our initial velocity in the y direction divided by the time is equal to the acceleration due to gravity, which is g. So when we rearrange this equation for g, or when we plug in that vi is equal to negative vf, we get that part right there, which is equal to g, and we could see that this is equal to negative 2 times the initial velocity, which is 20 meters per second, times the sine of theta, which is 30 degrees, which is equal to 1/2, which you will see us cancel out later. And then we divide, oh, you see my hair right there, that divided by 9.81 meters per second squared. That is equal to our time. Now, since, I don't know if I do it right here, but since sine 30 is equal to 1/2, we could cancel that and the 2 out on the top, and we get that this is equal to 20 divided by 9.81. And that part right there is negative. I forgot to write that in, I guess, but it doesn't matter. So yeah, the sine 30 and the negative 2 cancel out, and so does the negative. And we get 20 divided by 9.81, which is equal to 2 seconds. So that is how long it takes to go from there to there. Now, we do have an equation for this, which is Vx, which is constant, is equal to dx divided by time. That's just our equation for constant velocity. And we know our time, which we just solved for, since that is going to be the same. And we know our velocity is just equal to vi, which is 20 meters per second, times cosine 30, which is radical 3/2. So I will write that down right now. And those 2's cancel out right there. So we know that this is equal to 20 times radical 3 meters. That is our distance. I don't know why I said that equal to time. Oops. That's our distance in the x direction. And that is our final answer. I'm going to plug that into a calculator real quick. And we get that this is equal to 34.6 meters. That is our answer for our displacement. So I'm sorry that this video was done on a plate. I recorded this in Florida as I had to go very far away to take my SAT. I hope you enjoyed, and please like and subscribe for more, and I will be back to the iPad soon, I promise. Thanks for watching.